Alright, now let's look at this question. This is the first question. Always mark the keyword because marking the keyword will help us to arrive at the correct answers quickly and what the question is looking for. Please check out my other courses on Udemy by searching Cloud Guru Amit, where I have tons of courses related to cloud computing, that is Azure, Google Cloud, AWS, cybersecurity, management courses, and many more. And also, please consider connecting with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique, where if you need any kind of personal assistance, I'll be glad to help you out. Option E says apply a 5-year retention policy directly on the cloud storage bucket and lock it to prevent changes. This option is the most direct and enforceable method to guarantee immutability at the bucket level. Let's keep it. We'll move to option B and D together. Let's see. Option, if we look at this, organization level constraints define policy boundaries but doesn't enforce retention on specific buckets. Since therefore option B and D are incorrect. Now let's move to option C. C says encrypt the bucket using customer managed keys and rotate the key after 5 years. Encryption protects data confidentiality, not immutability or retention. Incorrect. We'll lock option A as the right answer. Let's bring the heat to the snow. This is all about 99.99% availability. We need to keep the cost optimized as well. Option A says deploy a high availability cloud VPN with 2 tunnels to a single on-premises VPN gateway. This option meets the 99.99% availability SLA required by the business. So let's keep it. We'll move to B. B says use a classic cloud VPN with 2 tunnels to a single on-premises VPN gateway. Classic VPN doesn't guarantee 99.99% availability as it lacks the high availability features. Incorrect. Now let's move to option C. C says provision 2 high ability cloud VPN gateways, each connected to separate on-premises VPN gateways with 2 tunnels per gateway. This is over engineered, I'll say, for the use case, which will add cost without adding value for the low throughput. So we don't want something like overkill, right? So this is out. We'll move to now option D. D says set up classic VPN, cloud VPN with 1 tunnel to a single on-premises VPN gateway. Single tunnel, if we look, will be kind of single point of failure, which will violate the high availability requirement of the question. So option D cannot meet the requirement. We'll remove it and lock option A as the right answer. Alright. Now let's look at this question. This will test your concepts on bring your own license, known as BYOL. Option A says export the virtual machine image from your on-premises environment, upload it to cloud storage, and then import it as a virtual disk into the compute engine. This option doesn't meet the bring your own license requirements, missing sole tenancy enforcement. Therefore, incorrect. We'll move to now option B. B says launch a new standard virtual machine in compute engine and select Windows Server 2022 as the OS during provisioning. So this option uses Google provided license instead of bringing your own, violating the again bring your own license requirement. Let's delete it. We'll now move to option C. Option C, if you look, this option attaches a data disk and doesn't address licensing compliance. It also lacks sole tenancy enforcement. That being said, C is wrong. Let's now move to option D. Option D, if we look, sole tenancy is required for Microsoft bring your own license compliance in Google Cloud, and the operating system, if you look, is 2022. Here we have the flag as well for it, which ensures the operating system is correctly identified for licensing purposes. Let's log this as the right answer. Alright, now let's look at this question. Option A says activate private Google access for sub A. So sub B is a kind of subnet. We have two subnet as per the question, sub A and sub B. So if you look here, private Google access only enables access to Google APIs, not general internet or public repositories. We'll delete this. Let's move to option B. B says set up cloud NAT and configure it to handle outbound traffic from sub B using NAT mappings. Cloud NAT allows private IP virtual machines to access the internet securely without public IPs, which is exactly what sub B subnet requires to reach external repositories. Let's keep it. We'll move to now option C. C says deploy a bastion host in sub A and route traffic from sub B. Bastion hosts are for SSH access, not scalable or secure for outbound package downloads. Wrong answer. We'll move to D. D says enable identity aware proxy IP with TCP forwarding to allow secure access to sub B instances. IP, that is identity aware proxy, TCP forwarding is used for remote access, not for enabling outbound internet connectivity. Incorrect. We'll lock option B as the right answer. Alright, we have a brainstorming question this time. Option A says configure CORS on the target cloud storage bucket to allow requests from the app engine, apps origin, and use signed URLs to enable secure direct uploads. So this option enables secure direct uploads from the browser without exposing credentials or routing through the backend. Let's keep it. We'll move to B. B says configure CORS on the bucket and assign the storage object writer role to users so they can upload files directly. Assigning storage object writer to users directly is insecure and hard to manage at scale. We'll delete this. We'll now move to option C. Option C says generate signed post URLs for cloud storage and use App Engine's default service account to sign the request. Missing CORS configuration, this misses the CORS configuration browser uploads will fail due to cross origin restrictions. Incorrect. We'll move to now option D. D says assign the storage object writer role to users and use App Engine's default credentials to sign upload request. So this combines insecure role assignment with missing CORS, not suitable for direct browser uploads. Incorrect. We'll lock option A as the right answer. Alright, now let's look at this question. This is all about requiring access to previous versions. Just by reading at this previous versions, you might be guessing the answer. This is slightly straightforward. Option A says bucket lock. Bucket lock enforces retention but doesn't preserve multiple versions of the object. It's incorrect. We'll move to now option B. B says object versioning. Object versioning allows to recover or reference earlier states even after updates or deletions. Let's keep it. We'll move to now option C. C says object change notification. Object change notification alerts on change but doesn't store previous versions. What's required? C is wrong. We'll move to D. D says object lifecycle management. Lifecycle management automates deletion, not version retention or rollback. Wrong answer. If you look at the official documentation, it's mentioned object versioning preserves deleted objects as version, non-current objects that remain accessible in your bucket until explicitly removed. That's what is required. We'll lock option B, object versioning, as the right answer. Alright, now let's look at this question. Option A says stabilize VPC network peering between VPC A and VPC B. VPC peering allows direct internal IP communication between instances in different VPCs with minimal latency and high throughput. Let's keep it. We'll move to B. B says deploy cloud VPN to create a secure tunnel between VPC A and VPC B. This option will add encryption, overhead, and latency. Not perfect for high throughput internal traffic. Wrong answer. We'll move to now option C. Option C, if we look, this option is designed for secure admin access, not for continuous instance to instance communication. We'll delete this. We'll move to now option D. If you look at option D, this is too much complex and unscalable. Also, this will introduce unnecessary latency and operational overhead. Therefore, this is not the good choice. We'll reject it. We'll lock option E as the right answer. Okay, let's look at this brainstorming question. As per the question, we need to reduce the infrastructure cost without affecting availability. Option A says create a separate GKE cluster, that is Google Kubernetes Engine cluster, dedicated to batch workloads, and split the existing 250 nodes between the two clusters. This option will add complexity and doesn't reduce total resource usage or cost. Incorrect. We'll move to now option B. Option B says apply CPU and memory limits at the namespace level and ensure all pods define resource request and limits. So this option improves resource fairness but doesn't actively reduce infrastructure cost. We'll reject it. Option C says enable horizontal pod autoscaling for stateless and compatible stateful workloads and configure cluster autoscaler to adjust node count. This option scales both workloads and infrastructure based on demand, reducing idle resources and cost while maintaining availability. Let's keep it. We'll move to now option D. D says reconfigure the node pool to use printable virtual machines. This option reduces cost but risk availability due to virtual machine termination. It is not at all suitable for all workloads. Wrong answer. We'll lock option C as the correct choice. Alright. Now let's look at this question. Option A says define liveness and readiness probes in the pod specification. These probes are native to Kubernetes and directly influence rolling deployment behavior. Let's keep it. Let's move to option B. B says set up health checks on the underlying managed instance group. This option applies to compute engine, not Google Kubernetes engine pods, which is irrelevant for Kubernetes native deployment. Wrong answer. We'll move to now C. C says implement a scheduled task that periodically verifies application availability. This option will add monitoring, but it doesn't prevent rollout related outages or misconfigurations. Hence incorrect. Let's move to D. D says configure an uptime alert in cloud monitoring. This option detects downtime after it occurs and doesn't proactively block faulty deployments. Wrong choice. We'll lock option E as the right answer. Alright, now we need to look for the first step to identify root cause of the performance degradation. We have a scenario here. Let's look at option E. It says start by analyzing cloud logging and cloud monitoring data from the affected virtual machine instances. This option is the most appropriate first step to diagnose the root cause, because before making any infrastructure or application changes, we can keep it. Now let's move to B. B says upgrade the virtual machine instances running the application to a larger machine type with increased CPU and memory resources. This option looks like a premature optimization without understanding the actual cause. Let's delete this. I'll move to C. C says revert the application database to a backup taken before the slowdown was reported. This option looks like a risky rollback without confirming the issue is database related. Wrong choice. We'll move to option D. Option D, if you look, architectural change doesn't address the immediate performance issue or the root cause. Therefore, option D is also wrong. We'll lock option A as the right answer. So please don't go away. Let's meet in next part of this series. Please check out my other courses on Udemy by searching Cloud Guru Amit, where I have tons of courses related to cloud computing, that is Azure, Google Cloud, AWS, cybersecurity, management courses, and many more. And also, please consider connecting with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique, where if you need any kind of personal assistance, I'll be glad to help you out. Thank you so much for watching this video. Please do consider sharing this video with your colleagues or friends so that they can also utilize the training program provided by NVIDIA.